estremamente stimolante è il surfing del C4I Star Wave. Quindi io vorrei spendere solo 2 minuti per introdurre il nostro ospite. Mr. William Power is a member of Lockheed Aeronautics Strategy Team supporting Lockheed Martin Advanced Development Programs and the F-35 program. Mr. Power served 24 years in U.S. Air Force as an experimental test pilot, commander, and physicist, and worked with many different and extremely performed aircraft, such as B-1B, B-2A, and was directly involved in the evolution of the RPA, such as MQ-1 Predator and MQ-9 Reaper aircraft. And Mr. Power has a flight experience on many different aircraft. And what is really exciting is to attend the presentation about this surfing the C4I Star Wave. Mr. Power, the floor is yours.
Thank you, sir, and thank you for the opportunity to speak at this conference. Being a Texan, English is kind of a second language for me, so I will speak slowly, not only as a courtesy to you, but mainly because I don't know how to speak much faster. So, a few weeks ago, I was asked by my daughter, just kind of out of the blue, and it really surprised me a little bit because mainly I live 100 miles from any coastline in the Dallas-Fort Worth area, and there's no surf in there. But my daughter asked me, "Dad, how do you surf?" And so, being a good modern father, what I did was I consulted the Oracle, otherwise known as Wiki. And what I found out was this, and I'll let you read through those. But big picture is that I found this to be a remarkably simple, but also a remarkably complex answer. And I saw in these pearls of wisdom that have applicability way beyond how one surfs, really. I'll add a spiritual element to that, and it's probably a good statement of how to get through life. But there's also a very good correlation to where we're at right now with C4I Star related technologies. There is a wave of converging technologies that, if capitalized upon, will carry us successfully forward, maintaining an edge for Western democracies in a militarily complicated world. And to capitalize on this wave, we need to anticipate the characteristics of that coming wave. We need to position ourselves optimally for success, and we need to complete necessary transformations before this wave passes us by. Now, naturally, with those sentiments expressed, and being in Rome, I have to pay some homage to one of my favorite air power apostles, your very own General Duhay, and his famous quote that victory smiles upon those who anticipate the changes in the character of war, not upon those who wait to adapt themselves after the changes occur. So sorry for that shameless plug, but more importantly, Duhay also said those nations who are caught unprepared for the coming war will find that when it breaks out, not only is it too late to change, but they cannot even grasp the drift of what is going on around them. So what does it take? Most militaries start with a military strategy. And from that strategy emanates all these threads of interrelated things. All of these interrelated but complementary and necessary and irreplaceable threads all form a cohesive tapestry that ends up resulting in a fielded force with competent and trained military people ready to do the mission that's asked of them. War and politics are always there as inseparable twins. The challenges of budgeting is always there. I think this conference's main theme of how to do more with less very clearly expresses that sentiment. Bottom line is that the raising of a military force is a completely underappreciated and amazing symphony. But of course there is a catch. Unlike George Friedrich Handel, who reportedly composed the major portions of the Messiah at a rate of 6 measures per minute, which is astounding, the symphony on the screen takes both time and it takes a lot of money. If I look at this chart, which is a little gem from the U.S. Defense Acquisition University that describes our very own acquisition process in the U.S. You put this thing up on a whole big chart, or on a wall size, it's not quite an eye chart, but this explains the entire budgeting cycle from cradle to grave for U.S. forces. Now, I don't think any of you, and even the most ardent advocate for the process that we have in the U.S., would ever look at this and have the word agile come to mind. So let's pause with that and let's take a look at what we all anticipate as the battle space for tomorrow. Tomorrow's battle space will be characterized by vast volumes of data flowing through thousands of networks, all with varying degrees of reliability. The decisive edge for future battle is going to follow a very familiar military historic pattern, and that is the side who can collect, process, understand, disseminate, and make decisions based on that information faster than their opponent is going to have a considerable advantage in the execution of the battle. Yesterday's pilot, if we think about early days in a 104, one of the most amazing, best airplanes, one of my favorites. In days of old, pilots spent years obtaining the skill to operate a mechanically scanned array, to pull Gs, to listen to analog radio calls where they're simultaneously digesting bullseye calls, bogey calls, bandit calls, keeping a situational awareness about them positionally in space, trying to figure out where their wingmen are. And all this was so complicated, but it was eventually mastered. The pilot of tomorrow doesn't have to do all that, because in a fifth-gen world, where we have advanced fourth or level 4 fusion, as they call it, we're going to have systems that allow the pilot to operate much more tactically and much more like a battlefield commander rather than, or a battle space commander, if you will, rather than just a tactical pilot. Bottom line is that the sheer volume of data is what we can really call as one of the primary challenges. And the challenge will be to constrain the data that is provided to that which is necessary and timely at a point where an empowered decision maker can execute on it. Tomorrow's battlefield is about advanced command and control concepts, network management, and management of both kinetic and non-kinetic effects. And I think that's very similar to what you've heard in several of the presentations thus far. I enjoyed the physics presentation, by the way, and I'd tell you that when there's an arc welder in my hand, there's no telling what the hell is going to happen. So I've been talking, of course, about the ever-present OODA loop. I hesitated even showing this chart at an Air Power conference because you all are very familiar with it, I'm sure. What I will say about it is that modern communication technologies make this particular facet of warfighting even more dramatically central to all that we plan to do and to secure our future success in warfighting. Combine all of the things that I've just spoken, and the OODA loop is both an opportunity, but it's also an amazing vulnerability. An amazing vulnerability. So, let me get back to my surfing metaphor. And by the way, I was assured by my Google search that there is in fact surfing in Italy, although it's not legendary, there is surfing here. So this isn't totally lost. So, in surfing parlance, the drop is what you call it when your careful preparation, your observation of that incoming wave, your careful positioning of yourself, and then the exertion of a lot of physical force right at the appropriate time and manner just to get you right in front of the crest of that wave just at the perfect time, and suddenly you're propelled forward as if by a seemingly invisible force, and you get to enjoy yourself and ride the wave. I think you probably see where I'm going with this. In our context, this is an information wave. And for the present, it's the only wave in sight, and it dwarfs all the other waves. You neither want to be the guys at the bottom of this wave who are about to get crushed by that monster wave, nor do you want to be the guys that are behind the wave, because they're out of sight, and they're irrelevant, and they missed the wave. So as Duhé said, they're also the ones that don't even understand the drift of what's going on in the front of the wave. So that's about all I'll make you suffer through that metaphor. Okay, so for the C4I star wave, what does it consist of? It consists of several things. Oops, I'm sorry. It consists of the combination of advanced data fusion and systems of systems, and I'll go into each of these topics a little bit more detail. It also involves the ability to have advanced secure communications, something that's always been critical in warfare, but something that the capabilities are really different today than they were just a few short years ago in the EM spectrum and the management and control of it. There are a lot more opportunities with emerging technologies for having assured comms than we used to have. More importantly, and as I alluded to earlier, we need to have flexible and adaptive acquisition processes, because I think we all understand. I showed you the U.S. system. I think many of you would argue that yours may be just as complicated, but I'd contend that most are not, and that there may be a lot of agility found in other allies' systems that could really advance the cause for ConOps development and acquisition of new systems. And more importantly, we need to change our approach toward command and control. Although it's been talked about for a long time, our formal doctrine in the U.S. is still centralized control, decentralized execution, right? That's a mainstay of air power. It's part of the dialogue that every airman learns as you're coming up through the ranks. But in fact, we hear our senior leaders talking about a distribution of control, and what I dub as a flexible distribution of control is going to be what's important. The ability to adapt in a dynamic way to varying levels of interference with our networks and with our comms. If you look at the array of systems that are in the Italian bag of tricks, there's also a good number of ways that those systems can contribute. This is a program that Lockheed participates in, which is the brainchild of DARPA, as one of our advanced R&D research organizations. I guess that was redundant. R&D organizations in the U.S. And what they see is that what we have today is very exquisite systems that are somewhat complicated, very difficult to field, and take a fairly Herculean effort to assemble these highly capable systems like F-35 and like F-22. And what they see in the future is a time where we more distribute the functionality of systems between UAVs and manned assets, between systems that are point designed. Harken back again to the 104, a plane that was designed just to be really freaking fast, and it did it just right. And it had a particular niche capability that it fulfilled in the battle space. And we could have common avionics distributed around a host of point design vehicles that were designed for specific aerodynamic purposes and to achieve particular mission sets, whether they be VLO required, whether they be no LO required, whether they be fast, whether they be slow, whether they be long duration or short duration. So DARPA sees a multitude of ways that their program called SOSITE, which stands for the Systems of Systems Integration, Technology, and Experimentation, can serve to help advance the cause here. They do believe that we have a very threatened technological lead in many ways on the current battlefield, and they do believe that we need to pursue distributed air warfare, where smart networks make decisions about how to apportion targets. And I don't want to get into an effects-based discussion, but essentially some of that same idea, where a smart network applies the force required to accomplish the given mission in the most efficient way amongst the available assets that are at the disposal of the commander. These are all things very important to DARPA and this SOSITE program. Robustness against cyber attack, also the common theme that you've heard here. Architectural cryptography, things that are advanced in terms of the way that we just hide key components of key memory blocks. All types of technologies like this are part of SOSITE. Another part of that is the exploration of open mission systems. For governments, open mission systems is about not being beholden to a contractor. It's about having an ability to adapt new hardware in a minimally invasive way at the lowest cost possible so that governments aren't wed to particular vendors for long amounts of time. They don't want to be held over a barrel in the proverbial sense by intellectual property that a particular vendor might have. So the government has defined communication standards. We have two that are under pretty high TRL states in the U.S., one called the OMS standard, which is largely supported by our Air Force, and another called FACE, which is supported largely by the Navy. In the end, there'll probably be some convergence of these two standards that will, whether it's going to be Sony or what, Betamax or VHS that wins the day, we don't know, but there'll be some standard that will apply toward open mission system approaches. And this has benefits for contractors as well. In the same way that it serves government's ability to do things more cheaply, it also serves OEM's capability to build products more cheaply and to meet our affordability goals in support of our customers. In the same way that it serves the government, it allows us to bypass level 2 or second tier contractors and actually reach down to a supplier base at a much lower level and secure, without a middleman in between, access to some of the more emerging and more promising technologies. So LM has a particular solution for this that we argue and that we believe is one of the most effective and actually goes way beyond what the governmental OMS standards are. But it's going to be very important going forward, and we can talk a little bit more about that, and I'd happily take more questions when we're not here or after the lectures. I'll be available for any other questions. The next point to make is that we have this elusive common operating picture. And fifth generation situational awareness is going to blur the lines between the typical strategic, operational, and tactical operations. As you are no doubt experiencing with your MQ-9 aircraft, suddenly when all levels of command get access to streaming video of critical target areas and things like that, suddenly the idea of having a common operating picture that operates across all levels of war and through time is actually achievable. And the goal is to have that immaculate situational awareness across the spectrum and to have no disparity between how that data is discerned, whether it be a low-level operator or a strategic level commander. As General North likes to say, though, good information's great, no information's bad, and bad information is way worse than bad. That makes good sense, but we do have cases where in our attempts to secure common operating pictures, we have had significant cases where the same picture has been diagnosed differently by different levels of personnel. And so standardizing the way that we approach, but also standardizing the way that we analyze and present that data is also very critical and another piece of this puzzle. So how we get all of this information together and share it and make use of it in the domains that are of interest to us, I'll talk about real briefly a cooperative engagement demonstration that we did with F-35s last September. Bottom line is this image is portraying a live demonstration that was performed at White Sands Missile Range. In this demonstration, radar data from an F-35, which was looking at a very distant operationally representative target, moving at operationally representative speeds, was the source which provided a targeting solution to one of our Aegis Ashore systems, which is essentially a mimic of the Aegis command and control system on our ships. That's just basically in a land-based configuration and is established in the ground there at White Sands Missile Range. So the F-35 provided through a relay this information directly to this Aegis Ashore system, which then used F-35 radar data exclusively as the targeting solution, and then launched an SM-6 against this target, which resulted ultimately in a very dramatic kill, and it was quite a successful experiment. In fact, the U.S. Navy intends to conduct another round of these against a different set of similar targets. But what this shows is, in fact, fifth-gen data moving across fifth-gen kind of data networks with fifth-gen speeds shared amongst assets that need it and can use the information is, in fact, a real thing now. And it's beyond just what one might do with air-to-air missiles. It's where you can actually move data fast enough to be of significant use to the Joint Force, to the naval leaders, to the land leaders as well, because these same things can work on terrestrial networks. So if you look at where that takes us for a common operating picture, this is just what we call an OV1 that shows the notional concept, where a bridge of these 5th-gen systems, and I don't mean to pretend here that F-35 is the system. It's the first to achieve this level of fusion and this level of transportability of data. However, it's not going to be the last, and there's going to be these same technological leaps for multiple different systems that have been talked about. So again, I'm not trying to have an F-35 commercial, but just to show that once you've got these kind of networks feeding your system, that can come across Link 16, it can be fed at high bandwidth rates right back to ground nodes, it can be tied into national assets. We have numerous experiments that are going on that are doing this right now. So what I'm telling you is that I believe that we are at the precipice where this idea that we've often heard about for the last 20 years of the combat cloud, of net-centric warfare, we've been taking little baby steps toward it, but we're at the point where we're about to start running, and it's not with scissors. We're doing a good job, and we're making some very significant headway toward making the combat cloud a reality. Systems like this could support any number of mission sets. I didn't go much into ground systems other than to say that you could pump this data back right now, just like we did in our demonstration, to terrestrial networks. And that information could go wherever it might need to. Now, of course, with the very complicated F-35 program, there's lots of policy things that have to be worked through and handled, but what I'm saying is the art of the possible is kind of an open door, and there's lots of room here for where we may go with this. So what are some of the key insights that we can take from this? Okay, first off, let's not play checkers at a chess match. We know where our challenges are. We know that our key adversaries, the ones that could actually pose existential threats to us, okay, are in fact working very hard on these same things. So we need to stay focused on operational innovation. Secondly, let's not be afraid to make an omelet. You need to break some eggs. And that might mean that you need to part with antiquity whenever required. Choose to not keep investing in an antiquated system that actually needs to be replaced. C4ISR is also a team sport. As I mentioned before, many of the allied nations might have better operational agility or acquisition agility than some of the U.S. partners might have. And they could bring a lot of merit to the table in many of these types of activities. I talked about cybersecurity, the ability to have maneuverable and resilient networks. But mainly, we just need to take to heart that C4ISR is, and having superiority in that domain is a never-ending contest. The game very quickly evolves, and you can never rest because the adversary is not in this domain, and technology marches on. Even when you might feel the urge to have a peace dividend, there are particular areas where we can never afford to divest ourselves of interest and financial support. And lastly, I'd argue that the future is usually far more advanced than we anticipate. And when we might be thinking that we're playing chess, we might actually find that we're playing 3D chess. And if you look historically at what the patterns have been, that has in fact borne out to be true. Now, I've tried to get through this fairly quick because I, like everybody else, appreciate al dente pasta, but I think I have time for a question. Maybe? One? No? Okay. Well, thank you.